Hello, and welcome to today's webinar on public key infrastructure for DevOps, hosted by DevOps.com, and content is brought to you by Sectigo. My name is Chris Riley. I'm a DevOps industry analyst and moderator for today's webinar, and I'm just going to start out with a few logistical items. You can hear us, but we can't hear you. So if you have any questions as they come up, please type them in the question dialog, and we will get to those at the end of the webinar. We're probably not going to be able to answer all the questions, but this webinar is recorded, and we will be sharing. We will come back to you with answers to those questions, or Sectigo will come back to you with answers to those questions in a few days. Also, because it's recorded, please share it with your peers once you get the email link to download that. So I want to go ahead and get started. I'm going to turn it over to Jason, who is the CTO of IoT at Sectigo, and Tim, who is the Senior Fellow. Take it away, Tim.
So thanks everybody for joining today. This is Tim Callan. I am a Senior Fellow at Sectigo. I'm also joined by Jason Soroko, our CTO of IoT at Sectigo. Say hi, Jay.
Hello, Tim. Good morning, everybody.
Thank you for joining us today. We do try to get this done. We have about 30 minutes of content for you today, and we do love questions. So please share your questions in chat, and we may take them in line if that's what makes sense for what we're doing. Or sometimes if we're going and we have a flow, we'll hold them for the end. It kind of depends on what it is, but we would like to hear your questions very much. Jason and I do a lot of podcasts together, so we are used to dealing with that kind of situation. We'll be able to monitor them at the same time. So Jason, today we are here to talk about DevOps. So PKI for DevOps. So start us off.
So in other words, DevOps, interesting term. I kind of like how the term development and operations kind of got smushed together into a new word. And that's really what it is. Yeah, exactly. It really does describe what it is. This is less about technology, Tim. It's more about people.
Yeah.
It's more about, if any of you have ever worked in a development environment, you may have come across situations where the computers that a development person may be using, the distribution, the operating system, all the different dependencies on that computer are going to be sometimes very potentially just slightly different than what might be happening on the operational person's computers. And when you add in the cloud and everything else going on today, there's so many different systems interacting. To make one piece of software work on one system and make the same piece of software work on another system is a real feat of achievement. And, Tim, I think that's the basis of why the DevOps movement and the DevOps culture has started. And we're going to get into concepts for how development and operational people can start to collaborate better.
And so having spent my whole life in releasing technology products, I know one of the things that we've experienced over and over again is, hey, well, that just worked fine on the engineer's system, right? That worked fine on the developer system, but it didn't work as soon as it got out into other environments. And so part of the idea of combining DevOps and operations is you sort of break down that barrier, and yeah, exactly. And then, of course, I do have a picture of Niagara Falls on the right, because the part of the point of DevOps is it's not your old-fashioned waterfall release kind of structure. It's much more agile. It's much more iterative and fluid and real-time.
Yeah, the whole idea being release cycles of software needs to increase. It can't be just, one version a year being released. We're talking now about, releases being done every week. And that's just being part of the discipline of a development team hand in hand with operations.
Yeah,
the ability to react to changes, the ability to develop software a lot more quickly. These are all very important concepts. And now when we're, as we're going to get into the next slide, I think the concept we want to introduce is even the way that software is being built is different. And I think that's where you're going with here, Tim.
Yeah, that's where I was going with, and I kind of got ahead of the slides a little, but we'll catch up.
Yeah.
You know, one of the things, and you've said this to me in the past, Jay, so I'm kind of stealing your thunder, is don't get virtualization confused with containerization.
Yeah, so we talked, a moment ago about different software platforms, different servers, different, cloud environments, all having different dependencies.
Yeah.
One of the ways in which we've gotten around that in the early part of the 20th century, virtualization, the ability to have a big honking server either in the cloud or on premise and multiple operating systems that are tuned just right to a particular, the needs and dependencies of a piece of software. That's fantastic. You even just on your laptop, Tim, can have, 14 different versions of Ubuntu running, all
Right.
completely differently configured, and they all do one singular thing well. If you take that concept one step further and you break it down into what is my fundamental problem? Do I actually need an entirely different operating system, or what do I really need to just bundle the dependencies together in a really clever way? And that's where containerization comes in, Tim.
Right. And so what it gives you is it gives you consistency of performance across a variety of environments, what we refer to as immutability, right?
Yeah, well, immutability is sort of like the holy grail at the end of that, which is containerization itself won't give you immutability. Immutability is when everything about your release cycle is completely codified so that you don't have any kind of configuration changes that are done manually. Every single release is a completely automated release.
Right. And so the benefit of immutability is
ultimately this problem that you described earlier, Tim, of, hey, it worked on my computer, why doesn't it work on your computer? Immutability completely, if it's done correctly, the theory is you should completely get rid of that because the entire configuration from soup to nuts is completely redone from top to bottom every time a release cycle occurs, whether that release is in test or whether that release is in live or whether that release is in QA or in some stage in between. Everybody's dealing with the exact same set of artifacts.
Right. And so one of the benefits of this, of course, as we start to get into our agile multi-cloud worlds, one of the interesting thing about DevOps, as you mentioned in the beginning, DevOps isn't a technology, right? It's a culture, it's a process, it's an approach, it's a method. But there are this constellation of things that sort of go with DevOps, and we'll get into some of them later. It's like orchestration applications. But another technology decision that accompanies DevOps a lot is multi-cloud, right? And is very highly mutable deployment environments, if you will.
Well, sure, Tim. This is just the same set of problems, similar to, hey, I have 3 different racks in my development room, my QA room. Every one of them is a little different, or in fact, every one of them is maybe completely different. Well, the way that you configure Azure or Amazon AWS or Google Cloud or your own, as they say, the rack space are again going to be completely different. So every one of these environments, whether it's any one of these public clouds or your own infrastructure, you should strive to do your software releases, your application releases in such a way that you should treat them in the same way that you might have treated back in the old days those 3 servers that sat in your rack mount. Yeah. Treat the cloud just like that, and therefore every single time you do a release, you've completely codified and controlled all the different environments and configurations. Everything's essentially automated.
Because we know what's going to happen, right? What's going to happen is you're going to want to repatriate these things between environments. So we're going to be running on AWS, and then we're going to want some of the special capabilities that are available on Azure. We're going to want to go over there. Or we're going to be on Azure and we're going to get a better deal on Google Cloud and we're going to go over there. Or we're going to have a major deal, but in order to do the major deal, there's going to be a requirement that it's on my bespoke hardware, and we're going to take it back inside. And so all of the, that just goes on. And in fact, it can even be split, right? A single work stream could have tasks that are running on multiple of these environments. And so this idea of a predictable environment becomes extremely important, right?
The promise of DevOps was all about getting things out faster, which means saving money, and also the ability to be flexible, so that if the pricing wars occur between AWS and Azure and all the different cloud competitors, if you're a CIO with a budget, you're very interested in being flexible amongst the multi-cloud environment. Therefore, these kinds of DevOps concepts also help you to save money in that way. So it all comes down to money, Tim.
Right. So it ultimately, though, it doesn't really look like this. This is an oversimplification. It actually looks a little more like this, right? So I have lots and lots of tasks, and they're all living in their own little contained containers. Is that okay to say that? Their own little containers, and they're interacting with each other all the time. And whatever of these environments they're sitting in needs to be irrelevant to their interaction.
Ultimately, it's all about loose coupling. It's all about all those concepts that were talked about in the mid 90s are finally coming to fruition, where finally, you can now really start to coherently decouple the way that software is built, so that software is built in small chunks of discrete pieces of logic, rather than great big monolithic pieces of code that are difficult to maintain.
So, but this changes the rules about identity, right? Because now, if instead of having a big giant monolith and that huge waterfall release we saw at the beginning, instead now if I have a whole series of individual tasks, individual actors, if you will, this opens up the door for a whole new breed of attack, right? Now I could have a man in the middle sitting in the middle of my work streams, pretending to be part of my work stream and stealing information, changing information, disrupting my business, etc.
Well, every one of these components could be talking across a barrier, a network barrier, and therefore, all those old concepts of man in the middle, all those old concepts of data integrity, those kinds of things increase that much more here, because as much as DevOps increases our ability to release software in a great way, that ultimately you now have a lot of discrete pieces of logic that all need to securely communicate with each other, which essentially screams for some sort of an identity security solution basis. Whereas IoT is all about physical devices connecting to each other. Now think about discrete pieces of logic that are connected to each other.
Right, and so it winds up looking a lot like the public internet, in that you can't really trust any actor that you encounter unless there is what I'll say is a hard identity in place.
Yes, absolutely everything is going to be communicating over some sort of threatened environment, the public internet. And so therefore, we need to look at solutions that traditionally have been able to protect that, but can then scale so that these discrete pieces of logic can then communicate with each other. Thankfully, the technology for that is now evolving and does exist.
And this, of course, is PKI.
Yeah, PKI, which is proven, reliable. It's been around forever. It needed to rise to the challenge of just the scale of it needed to rise to the scale of IoT, and also needed to rise to the scale of sometimes logical identities that might have a very short lifespan, which wasn't a common use case for PKI, but thankfully we've evolved.
Yeah, so let's get into that. So how is this PKI different from a traditional infrastructure? You talked about the short lifespan. Just elaborate on that a little, right? So we've got a DevOps task. A container only lives as long as that task is running, which could be minutes, right?
Yeah.
And
Yes, and additionally, even if it's a serverless function, it could be sub-seconds to bring it to its most extreme conclusion.
sure.
But some containers may stay up for a month. So in other words, there's flexibility as well as the shortness of the lifespan. There's also a flexibility of sometimes I want it to last a while, but I also want to, because it's going to last more than a week or 2 weeks or a month or a year. Perhaps I also want to be able to do revocation checks. So it
Right.
brings in all those PKI concepts.
Yeah. Now, at
And
the
I
same
like what
time,
you.
go ahead.
No, please, Tim, go ahead.
I was going to say, so at the same time, though, I think the average, if you think about sort of a traditional, if we think back to our old traditional, I have a server farm, sitting in a locked room with aircon and a drop floor, we put a cert on a server and we don't touch it for years. And I install the cert and I can rely on the fact that I will celebrate 2 birthdays before I need to worry about that cert again. And this is no longer that world, right? I mean, something could last a second. It could last even a month. Hypothetically, it could last a year, but they almost never do.
Yeah.
And so the average lifespan goes down dramatically, orders of magnitude.
Yeah, and you're talking about live systems, Tim. I think
Right.
where a lot of the unpredictability comes in is these exact same systems are mirrored in QA and test platforms.
Right.
And those QA and test platforms might, in a live environment, that system may be up for that year or 6 months. Whereas in a QA environment, it may be going up and down multiple times a day, even though it's serving the same function, but because of the environment it is in, its lifespan is much shorter. That makes it very unpredictable.
And even in the live environment, correct me if I'm wrong here, Jay, but to some degree, you don't know that the cert needs to be issued. It's all very just in time, right? So a task occurs, a seldom used or a need occurs, a seldom used task gets spun up. You don't know exactly what minute of the day that task is going to be spun up, and what you need to do is you need to provision a cert in real time to deal with that container that's being created in real time.
Exactly. A variance of lifespans. The only thing you can be assured of is it's probably a large number of certs.
Right. So just as the lifespan goes down by, order or orders of magnitude, likewise the number of certs increases proportionately. Again, order or orders of magnitude, right?
Absolutely, Tim. And you know what? I think what the concept we need to move now to is another form of complexity, which is the number of orchestration applications. So not just orchestrating the certificates, but orchestrating the containers themselves, and automating the release cycles. We provide a number of logos here that probably most of you are familiar with if you're interested in DevOps. But keep in mind, Tim, you could have spent the entire weekend putting logos on this slide, because there are dozens, if not hundreds. The richness in this ecosystem is so incredible, of the number of, if I'm a CIO and my DevOps people are showing me just the sheer number of tools that they're using. I've never seen anything like this before. I bet you 3/4 of Silicon Valley right now is building some brand new DevOps orchestration system that handles a niche, right? And this is we're speaking to just another level of complexity here.
Yeah, and it's all evolving so fast. To your point, like how many of these logos would we have recognized 5 years ago? And yet now they're considered to be just basic tools today.
Yes, absolutely. Right now, this is the one question I get from some people who haven't been involved with DevOps is it a fad? Is it something like an ITIL? Is it a cultural change that just a few people are enacting? Geez, I don't know too many enterprises right now that aren't going in this direction and using tools just like this.
Yeah, DevOps is not a fad. So okay, so these popular DevOps tools out of necessity have their own CAs because they built their own CAs in because otherwise we have the problem that we covered on the previous slide, right? Where you have man in the middle or identity problems. So I guess maybe
Even
we
more
should.
scary, Tim.
Mm-hmm.
My apologies, Tim. Even more scary than what you just said. I would say out of the 6 logos you have here, I think only 2 of them actually have what you would call a CA. The others, in order to have a certificate authority, actually force you to go off and run some Linux commands and fire up some sort of open source CA system, and then you cross your fingers and hope for the best.
Right, exactly. And so let's go ahead and let's move into that. So where's the risk? Like I listed some things that can happen here, but let's just talk a little bit about the risk of having, let's call it poor PKI or sloppy PKI that has been forced upon you running on these mission critical systems.
Well, the top one on your list, breaches or unauthorized access. If you think
Right.
about, a certificate authority, if the bad guy is able to somehow get control of that, and if you think about it, if your CA is just some open source thing that's underneath a desk or wherever it happens to be running, even if it's just in the cloud, how are you protecting that? How we run certificate authorities for public trust, Tim, and the sheer amount of work that it takes to do that correctly means that there are only a few public trust CAs, out there that do this at scale.
Yeah.
And so therefore, to expect just the average, DevOps personnel to fire up a CA and protect that correctly, I just don't believe that. I don't believe that those CAs right now that have been spun up over the last couple of years for DevOps purposes are at all protected from breaches or unauthorized access. If those breaches or unauthorized access happens, your entire web of trust can be unraveled, leading to things that are obviously your worst case scenarios, which is operational disruption. And obviously, if somebody's going to audit you for how your DevOps is being run, you could be in non-compliance, which is going to be to the person who set it up, hey, it's just a set of tools, it's just a set of technologies. You might not realize that, trust basis technologies such as PKI, there's a right way to do it. And that right way to do it is so difficult, you probably shouldn't be the one doing it.
Right. So who should be doing it? So what does a third party give us? We kind of covered this already, but there is a security aspect, obviously. Third party CAs understand things like key lengths and hashing algorithms and physical security and IT security, and they make sure the patches are in place and all of that stuff. But walk us through, and then compliance, I think we also covered, right? The CA understands, the public CA understands what the major compliance requirements are, because they have to service tens of thousands, hundreds of thousands of businesses around the globe. And so, for instance, you know how to make sure that you're not violating GDPR, by way of example. Go ahead, Tim.
Yeah, Tim. Yeah. So your three of your bullet points here: the secure, reliable, and compliant. We could go on about that, but let's talk about interoperable just for a moment here. Yeah. You might set up a CA for your environment, and hey, that's great. Maybe you even have somebody on it who's got some experience and knows what they're doing. Let's just say that. The problem is you won't be trusted beyond your own walls, and so therefore, if you don't just want to work with your hybrid cloud or your multi-cloud environment, which is essentially an interoperability between those clouds that you have control over, all of a sudden, if you want to do something like work with your partner cloud, right, your partner will also have their own, internal rack mount. They'll also have their own public cloud resources. They'll also have all kinds of other things that you might want to interact with your DevOps containers, etc. So therefore, if each of you as a party, as a singular party, has your own CA, how do you make those CAs trust each other? Well, they won't. They're not
Right.
rooted to something larger. The trust model hierarchy is wrong. Therefore, that is one of the main purposes of working with a trusted third-party CA, so that there is a higher order trust organization that gives implicit trust to each of the third parties that needs to be able to interoperate. This is a major concept that I think a lot of people right now are scratching their heads. How am I going to solve this? Well, the answer is you don't solve it on your own.
Yeah, and that is where, these solutions that were provided by the orchestration apps, even if they do offer, whether they're offering their own CA or whether they're pushing you to this other CA, that interoperability thing, no matter how rigorous your own knowledge is in operating your CA, that interoperability cannot be achieved without publicly trusted routes. And that means you need to go to a source of publicly trusted routes, right, Jay?
Correct, Jim.
All right. So, but then there's other things, right? So once you go to a third-party CA, there are other benefits that come, and I just made a list of them here. So, talk about code signing in a DevOps environment.
Right. So the integrity of your code, you might even have a perfectly immutable software release setup, and you can put your feet up on the desk and say, hey, check me out. I'm awesome.
Right. Yep.
And if I was one of those devs, that's exactly what I would do. The problem is, let's talk about security for a moment. How do you know that automated release is your code on day one and your code on day two?
Yeah.
How do you know that code is, the integrity of that code is ensured? Well, the way you ensure that is to code sign. And so when you're dealing with a trusted third-party CA, we offer code signing services. It's just what we've been doing for years and years. It's just now we've brought that into a DevOps environment.
Yeah, so this is a valuable point to make sure that it's clear, is the DevOps environment, the containers are going to take the code that has been prepared for them and they're going to run them. And certificates on containers ensure the identity of that container, right? That is a real container. That is not a rogue or fraudulent or spoof container that's here to penetrate my systems and do something bad. However, if you're legitimately containerizing code that was tampered with before it ever got to Docker, then you still have a problem. And so what code signing does is code signing ensures that the source of that code is what is expected and that it has not been tampered with since it was originally published. So the two of them work very closely in tandem, and they do different things. And so it's good to clarify that. Second one, single root for all applications. I think we touched on this already, right?
Yeah, you don't want to have a ton of CAs running. You may have certain reasoning to have a trust model where every one of your applications or every one of your Kubernetes clusters has its own CA running. In reality, you probably don't need it like that. And so therefore, if your organization should trust itself, it's almost silly to say, isn't it, Tim? If your organization is willing to trust itself,
Right.
You probably want to single root all your applications so that if you ever wanted to do interoperability amongst the applications, that ability becomes possible.
Yeah, and it just, one of the other things that we see in the DevOps world is you get this distribution of tasks among different parts of the organization, right? You get this organizational distribution, and this leads to a lot of coordination requirements. This group in Milwaukee is doing something, and my people in Los Angeles don't even know about it. And so if you can put everybody on the same route, you can prevent one of the potential problems, which is systems that are supposed to work together and we're working together in isolation suddenly start to break down when you're trying to have them talk to each other. And if you just build that in from the beginning, you eliminate that potential point of failure.
Right on, Tim.
All right, HSM protected private keys.
The term private key kind of implies that you don't want those keys to be floating around.
Right.
And, for those of you who are not aware, HSM stands for Hardware Secure Module. And really, that's a piece of physical hardware that I was involved back in the late 90s with HSMs. So this is not a new idea. We're taking an old PKI idea that is a good idea and saying, look, your private key should be in a very, very safe place. And that safe place isn't an HSM. And so for those of you who are running DevOps right now and you're not utilizing basic, key protection mechanisms for your private keys, you're really missing out on avoiding being at the next black hat as an example of how to do things wrong.
Right, not on stage either. Yeah, so you mentioned this a little bit earlier, but multiple Kubernetes clusters.
Right. So, here's a question I get quite often. Hey, Jay, I run more than one Kubernetes cluster. I'm told I have to run a separate CA for each of them. I haven't figured out yet how to do a single route for all my different Kubernetes clusters. Goodness, I think that there's a perfect example of why you need to come to a third-party CA, because figuring out how to do a singular CA for multiple Kubernetes clusters, I know it can be done. Should it be done by you is the bigger question.
Right. And then just clarify. So if we're using this, if we're getting the root trust across multiple clusters, is this accomplished using a publicly trusted root, or is this accomplished using a single, what we call a private PKI or private CA root with yourself as the CA at the top? Or is it really dealer's choice? Is it whichever one the enterprise prefers?
I would say I would hazard to say it's more than likely mostly going to be private trust. In other words, it's a
Gotcha.
walled garden of your definition. There
Right.
may be use cases where you need public trust, but I would think that in the most of cases, it's private.
So in these scenarios, you can stand up a nice private CA with yourself as the ultimate trust authority at the top, and this will work very well and be very effective.
Yeah, and the beauty about that is, Tim, one of the things that held back PKI from being in a lot of different use cases over the past, decade or so is all the different public trust, all the audit, certificate compliance stuff, that just the sheer amount of paperwork it takes to do this right, so that you can audit yourself correctly. Within most private trust situations, you can simplify that and stand up that infrastructure a lot more quickly than you could if it was public.
Right. So again, that helps with the whole agility thing. So, and revocation checking. So to your earlier point.
Yeah. So in IoT, we see revocation as an example in IoT, and I'll just use this as an analogy. But for the most part, IoT is all about using somewhat shorter lifespan of certificates and getting away from revocation, because the live usage of an IoT device, you typically don't want to revocate it while it's actually doing whatever it is physically doing. Yeah. When it comes to DevOps, again, it might be dealer's choice, where the lifespan of the container is so short, no bother in revocating it. However, for longer lifespan environments, you might want to say, all right, I want to revoke the certificate as soon as I know my process is over. Therefore, I don't just have a certificate lying around that is valid, that could have been stolen and perhaps used as a credential to do something. Therefore, for longer term, longer lifespan use cases in DevOps, revocation actually starts to make sense. And again, that's something that a trusted third-party CA can provide to you.
Yeah, third-party CAs have to do this, right? Because out in the real world and with the multi-year, kind of long-lived multi-year certs that operate in the public infrastructure, revocation and operating revocation real-time and at scale, and with high uptime is an extremely important part of being a successful public CA. So, a third-party CA has to know how to do this. They have to be able to handle the volume and the uptime and all of these requirements. and fast checking, speed to checking, all of that needs to be in place. So that is absolutely something that CA can help you with. And then other keys, right? It's not just, you're not just going to be using them for your DevOps environments. You're going to need other cert types as well.
Well, I think the key here, Tim, is imagine having a single pane of glass to manage your public TLS, your SSH, your SMIME, and your DevOps certs, and heck, even whatever you're doing for IoT. Imagine having a single management pane of glass. I think for the CIOs, CISOs listening, that ability for you to look at everything and manage everything in one spot, that's something a trusted third party can give you.
Right, and that helps. And then there's other things. Once you're getting into this world and that pane of glass, there's capabilities that you can be offered, like certificate discovery, automated deployment, full lifecycle management, automated renewal notices, all kinds of things that become important to prevent outages and breaches and compliance problems and the other things on these other set of certificate types.
Yes, you got it, Tim.
So we promised you a half hour. We didn't quite keep there, but we were close. As I mentioned in the beginning, we do this a lot. So if this sort of information is interesting to you, Jason and I run a PKI and security podcast. From what I can tell, it's the only thing of its type, where we, on a pretty regular basis, go in and we dive deep on various issues involving the world of PKI, certificates, trust models, encryption, things along those lines. And we're available on all the popular streaming services. If you search for root causes, PKI, you should find us on any of these services.
Great, Tim. And guys, this was awesome. I even learned a lot here. We're going to get into questions here in just a second, but I want to remind everybody something, shame on me, I didn't mention at the beginning. We have 3 AWS $50 gift cards that we're going to give away. I'll announce those names at the very end. If I announce your name, we'll be reaching out to you, letting you know that you're a winner. And also a reminder that this webinar was recorded. So if you have any questions, please type them in the question dialog. If we don't get to them right now, we will follow up and get to them after the webinar, and make sure you share the recording with your peers. So I'm going to pull moderator privilege here, and I'm going to start with the first question. Because I think that you guys highlighted really well the challenges that come with this new DevOps mindset. And I think this actually addresses a lot of questions, and it comes up a lot. You talk about, all right, you shift left, the concept of developers taking on more burden of the delivery time. We now have DevOps engineers, which is a somewhat new role, not very, very new. But classically, these aren't the people who have been managing certificates. So who manages the certificate authority and the management layer of the certificates? And do you separate traditional certificates from DevOps certs?
I can take the first question. The who should run it? I think that was the basis of what this webinar was. It shouldn't be you. It shouldn't. If you are in any of those roles, you should really think about certificate management, such as if the toilet explodes at your house, you can probably grab a wrench and maybe try to fix it, but chances are you should call the plumber. And I hate to make the analogy, but we're kind of like the people you call. A trusted third party is who you would call when you want to do this correctly, and therefore, the setting up of a certificate authority and the managing of certificates should be done by the people who know how to do it best. And believe me, in the long run, outsourcing that to the pros will save you time and money, and absolutely will save you from being, the poster child at Black Hat for how to do CAs wrong.
So Jay, let me ask a slight variation on that question. What would be the best role, the best internal role inside the company to manage that relationship with the outside CA. So let's say we say, yes,
Sure.
you're right. I want an outside CA to do this, but I still have an owner inside the company. Where should those owners sit?
I like to start top down, Tim, whenever we ask a question like that. So typically you're going to have, some organizations, many organizations now will have a risk officer. That risk officer should be mapping out, hey, we're using trust material, key material in our organization. How is that being managed? What are the risks associated to being mismanaged? What happens if we lose key material? What happens if it goes down? All those things are at the interest of the risk officer. If your organization has that, maybe that's where you start. Failing that, if you have a CISO who's a CIO who specializes in security, if failing that, if you have a CIO or a director of IT, but for organizations that are more, in the act of building software and they're less enterprise, that position might be, if it's a small organization, it might be a product manager, right? So in other words, I think the point I'm trying to make is it's not going to be the person who is doing the development, the person who's down at fighting in the trenches. This needs to be a top-down driven kind of endeavor, where if you as the developer or you as the QA person, you as the operations person know that you're handling key material, you need to elevate this to some higher level of the organization to say, hey, this is risky stuff. It's really not my responsibility to, it's not my mandate to protect the company. I'm in the business of building software. I'm in the business of testing software. This needs to go to some officer in the company who does have that responsibility. Elevate it. It should be top down.
And somebody who has visibility on the entire footprint of how that particular application is being used.
Interesting. Yeah, and that's, I guess, part of the challenge with anything DevOps is, a lot of times bottom up, they understand what needs to be done, but if you don't have the executive buy-in, it's really hard to sustain and execute. That's great. So here's another really good question from the attendees. When you look at DevOps environments, and you talked earlier about the idea that these certificates have much shorter lifespans than they used to. Now, we also have many more kind of temporary environments, especially in quality assurance. So how do you see, or what are the recommendations for using certificates in QA environments?
The ability to stand up a server, the ability to stand up a server and break it down right now is just so fast. Having a CA in the background that is very, very agile, I think the way to solve those two chicken and egg problems there is to integrate the DevOps Certificate Authority tool into the tools you're already using on a daily basis. You might recall that slide where you saw Jenkins and Kubernetes and some of the other tools that you might be using. To seamlessly integrate the Certificate Authority tool set from the trusted third party into those things, that's the answer.
Got it. Yeah, that makes sense. I mean, in a big way, it really needs to butter across all of your environments, like you said before, seamlessly, so that it isn't really a primary consideration, that developers or any individual has to make on, how they're going to leverage it. They just do it.
The QA person and the dev person should be doing QA and dev. They shouldn't be doing security. It should be built right into the tools that they're using. That was the design philosophy behind how we wanted to interact with those people.
Mm-hmm. Excellent. So another thing, you mentioned multi-cloud earlier. Another thing that is in a revitalization right now is hybrid cloud. What does the public certificate authority look like in a hybrid cloud type environment?
Trusted third-party CA essentially would be its own cloud. So in other words, the issuance of certificates going between all these different environments would actually be coming from just another cloud. But that the way that the trust hierarchy is set up is that cloud is doing the issuance that is implicitly trusted by every one of the other systems, whether it's cloud or whether it's in your own rack mount. So in other words, the way it's solved is the trusted third-party CA manifests itself as just another cloud issuance platform.
Right, and the nice thing about it, especially if you have, we referenced earlier this single CA, is that you can have a single PKI implementation that really can work in all of these environments. Like hybrid cloud, it is a technical term, but a lot of times when people say hybrid cloud, what they really mean is sort of going back and forth as I want between these different environments, and it's used kind of loosely that way. And when you look at it that way, the single CA winds up being very important because that gives you that interoperability that we're talking about before.
Right. And hopefully, in this leads to the next question.
Mm-hmm.
DevOps is, relatively new. I'll say, in the area of SecOps, and we're getting to the early majority, and we're starting to get really real about things like certificates and security and so forth. Where does somebody go to, and are there best practices for things like automatic renewals, manageability, et cetera? Like, how do people even know that they're doing this correctly?
Yeah, I mean that's a big one, right? We routinely deal with even large enterprises that don't necessarily understand the full suite of capabilities that are available to them. We referenced this earlier when we talked about, but things like automatic renewals are incredibly important. If you think about the O2 outage that happened in December of 2018, where 30 or 40 million people were without phone service, that ultimately owed itself, if you take it back to the root cause, to an expired certificate. If you think about the Equifax breach, where 45% or so of everybody in America had their personal identifying information stolen, including me, by the way, that the root cause of that was a certificate outage, or it was enabled by a certificate outage. And so, by a certificate expiration. And these are just certificates that are allowed to expire because someone doesn't know they're there, or knows they're there but doesn't do what they need to do to solve them. So these are very real pain points that hurt enterprises all the time. And so just good old-fashioned automatic renewal, certificate discovery, alerts, or just getting a report in a pane of glass where you can see what you have and what's coming and what needs to happen are very valuable to the enterprise. And even if we feel like these things seem pedestrian, they're still not being handled. Routinely, they're not being handled. And so to the degree that we can communicate to enterprises that automation and software can help them, get away from this, I'm depending on a human to open a spreadsheet and take action on a certain day kind of philosophy, the more that we can get away from that, the better off performance is and security is for large enterprises.
Yeah, and so it sounds like kind of the best practice zero is do something.
Yeah. Mm-hmm. And do something automated. And one of the good things about the DevOps use case that we talked about here is you really have no choice. Human management of certificates is no longer possible. So it must be automated. And hopefully then it's easier to take the leap to say, well, gee, why don't I do the same thing for my other certificates?
Yeah, good point.
I'm gonna add just one piece to that, just while I'm thinking about it. Most folks who are involved with DevOps at all, hopefully every one of the listeners here on this webcast, you've all been dealing with things, like SSH keys, and what the implication of losing those keys are, or having them stolen. This is really what the types of containerization CAs that we're talking about on this webcast, it's no different. It's scaled that much larger. You don't want to lose the keys to your kingdom, and you don't want to lose the ability to, to have that trust anchor of your CA unravel. It's just the implications are similar to your SSH keys. It's just these certificates, the entire trust system could unravel. I think for those of you who've never thought about security much before, you can at least understand it from that level. This isn't just, setting up a Kubernetes cluster CA isn't just about getting it to work. It is about setting up a trust mechanism. And therefore, this is why we're trying to make the argument, let people who do those trust mechanisms well help you to enable them.
Great. That's great. So kind of similar, and it all comes down to, what we talked about before, having executive buy-in and so forth. And we see this in the public cloud when it comes to costing of infrastructure. With traditional CAs, it was pretty straightforward. And you talked about it earlier, set it and forget it kind of mentality. Because of these, fast moving environments, what do organizations need to think about when it comes to, the cost associated with a public CA?
Right. Standing up the infrastructure is something that can be done quite rapidly. So it isn't just about cost. It's quite often PKI has been thought about traditionally as being something that is difficult to stand up or is lengthy or requires a lot of professional services. I think what's happened in PKI, it's evolved to the point now where the standing up of that infrastructure is very quick, and therefore a lot of costs associated with things like professional services, that's mostly gone away, unless you have something that's very, very custom. The cost of the standing up the CA itself can be quite reasonable. And in terms of the way that certificates are sold, there are obviously tiers, of pricing. If you're really low volume, there'll be a certain pricing. If you're an extremely high volume, there'll also be pricing. But we're not going to be pricing this the same way that you might be selling a, SSL certificates, an EV certificate price. That's definitely not the price point that we're talking about. We're talking about orders of magnitude less, which makes it actually quite cost efficient. And if you think about the management capability overall, your total cost of running this kind of PKI infrastructure through a trusted third-party CA is probably way lower than doing it yourself when you consider the amount of work it's going to take to do things correctly yourself.
Great. Yep. And obviously, everybody has to deal with budgets, and this is an important thing. And I think a lot of organizations don't realize, how much how much their internal costs are when they do try to implement things on their own. So that's a big deal. Well, in the last little bit, it strikes me that we're now having a webinar on kind of addressing some of the challenges that were created with new methodologies, new environments, new tooling, serverless and microservices and containers and Kubernetes. What do you gentlemen think is the next maybe challenge that we have to address in, the area of application development and infrastructure? Or, what are you most excited about in the next, 2 years?
Tim, I think that we could go off and dream about the sheer amount of interoperability. I think that's one thing the DevOps community hasn't reached yet in their thinking is most of the builds that I see today are mostly in-house for singular purposes, and DevOps is really helping. I think that DevOps becomes incredibly powerful when you start to not just create interoperability between the staff members of development and operations, but also then create interoperational capacity between partners so that software can be built between organizations and then everything just kind of hangs and meshes together. So think hybrid cloud, multi-cloud, multi-organizational development. I think that's coming. And therefore, thinking ahead towards interoperable trust models such as trusted third-party CA, certificates authorities that are essentially hosted by a third party so that you can create that interoperable trust model. I think if you're thinking ahead, interoperability might be the key word overall. And therefore, future-proof yourself and talk to a trusted third-party CA.
And Jay, when you mention future-proofing, how my answer to that is going to be crypto agility. So one of the things, we've actually talked about this on our podcast, so I'll put that back up. One of the things that is very interesting is how quantum computing is going to force changes to the fundamental cryptographic algorithms that sit behind our common PKI, right? Your RSA-based algorithms aren't really going to be reliable. Your SHA-1 isn't really going to be reliable. We're going to have to go in a different direction. And so being able to be agile in what the cryptography is in our systems in a pretty reasonable time frame becomes extremely important. And so, we're moving into a world rather than a world of kind of static cryptography, cryptographic structures that endure for decades. We're moving into a world where we're going to need to be able to adjust as research advances, as computing power advances, and as fundamental computing paradigms advance. All of those things are going to force our cryptography to be much more dynamic.
Interesting. Yeah. And I, Jason, I really like the idea around the, or touching on the fact that, we are going to be consuming services from each other as well. So that dynamic nature of cryptography is going to be necessary, in the economy of, services and how our applications communicate. So that's really interesting. Well, Jason, Tim, thank you very much for your time. I'm going to read off the winners of the AWS gift cards. Before I do that, again, I want to remind everybody that this is recorded. So once you get the recording, share it with your peers. And also, there's a few questions that were not answered completely, that some of them were very technically specific, that we will answer offline, and you'll get a response via email on that. So let's do the Amazon gift card. The first winner is Arnab B. The second winner is Daryl C. And the third winner is Michael L. So congratulations to those winners. You will get an email with the information for those gift cards shortly after the webinar. And Jason, Tim, thanks for your time. And I think people should go and check out your podcast. It was a lot of great information today.
Thank you so much, Chris.
Thanks.